It's magnifying. For example, say that this is 3,000 volts here, and we have 10 turns here. So this is volts, and we have 10 turns. Okay, we divide 10 into 3,000, and that means that each turn is going to equal 300 volts. So each turn on a L2 coil here, each turn on there will have 300 volts on it. So if you have 30 turns, you've got 300 times 30, which would be, let's see, 300 times 30. Okay, and that's going to be 0.009. So you're going to have 9,000 volts on your L2 coil.
Okay.
Okay. It's going to do that irregardless of the amount of turns or the frequency or whatever. What we're doing by forcing the 35,000 cycles per second onto this first coil, we're forcing that second coil to duplicate the same thing, as long as it's an even division of or multiple of the wire length in the first coil.
Okay.
So we've got, at this point, we've got 9,000 volts out, and we probably will want to put a spark gap of some sort in here so that we can, and this goes to your earth ground. Okay, and this center part of the spark gap will go to earth ground.
Okay.
Okay, and this is going to limit the voltage so that it's within the range which you can handle it with whatever device you're going to load this with.
Okay.
So you can go directly from this into your transformer out here, and it'll be an isolation transformer. And at this point, what you have to do, since you've got a frequency which the isolation transformer cannot use, you have to correct the frequency. So in order to correct the frequency, you put a resistor across the two poles there. In order to determine what resistor size you use, you go to either the American Radio Relay League chart showing capacitance and resistance and other types of things, which will tell you what approximate frequency you'll end up with. Now, in the case of American Radio Relay League, you're going to be off the end of the chart, and you're going to have to take a little piece of paper and make the grid and extend the chart over about an inch or so and about an inch or so down in order to get, say, 60 cycles or 120 or whatever it is you want. But you can do that real easy.
Okay.
So anyhow, we've got through our 12 volts, and none of the electrons from the 12-volt battery have left the high voltage module. The high voltage module has excited electrons in a separate, just like your transformer here, where you have the two sides are separated from each other, so that none of the electricity on this side actually goes through the system. And what it does through induction, it excites the coil on the other side, and your electricity over here is coming from the earth grounding, and your load is going to be in between the earth grounding and the other pole of that transformer. And you're going to have to also put some sort of voltage control on this thing here, and that will be a varactor, V-A-R-A-C-T-E-R. And what that is, like on your computer where you have a voltage control thing that keeps the spikes from coming in, it looks like a little capacitor, but it's not.
Okay.
But it basically will limit the voltage to some level which is okay for the device that you're trying to run. Now, what I have shown you here, you don't have to know how to tune it. that takes care of itself for you, and you have to make only one correction in the frequency, and any coil and resistor or any coil and capacitor or any combination of those will give you a particular frequency. Now, Radio Shack has a book on electronic tables and such, and you can use the charts in it.
Okay. Is this the smaller, simplified version?
No, there's some solid-state versions of this where all of this is thrown out. But I'm not at liberty to talk about them just now.
But this can give somebody an idea that you don't actually have to come.
You don't have to know what you're doing at all.